Okay, so we're going to talk about a little bit about similarity. It's one of the more interesting things that we do in this class. If we could do a little bit more. But similarity, two figures are similar, two figures that are the same shape. But not necessarily the same size. Okay, when we talk about similar figures, the angles, the corresponding angles will be congruent. So, corresponding angles are congruent. The other important thing is the ratio of the sides is proportionate. Okay. So, and we'll talk about that a little bit, about what that means. Similarity statement, just a statement that two figures are similar. Okay, this right here is a similarity statement. It means that like ABC could be something like this, ABC, and then MRG could be like this. They're similar, same shape, but not necessarily the same size. If that is true, then angle M would have to be congruent to angle A, and so on. All right, and this is something that you did in middle school. It also says that side RG over side BC, so last two letters, is equal to side GM, first letter or last letter, first letter, over, and then it's going to be first letter, last letter over CA. Okay? Basically, what that means is if I said this is 2 and this is 1, if I told you that MG was 6, you tell me that AC would have to be 3, because 2 over 1 would be equal to 6 over 3. Okay. And then lastly, you have MR, so first letter, last letter, so you have MR this side right here, and then we have MG this side here, is equal to, well, what side corresponds? So MG corresponds to AC, so what side does MR correspond to in the other? Well, that's first letter, second letter, it's going to correspond to AB. Next thing is scale factor. And scale factor is it's the ratio of the sides. It's what you use to multiply one figure to get to the other. A part of one figure to determine the measurement of the other. Okay, so it's what you multiply one part of one figure to determine the measurement of the other part. Excuse me. How you find it is it's actually going to be, you find it using the ratio of the sides. And it's always going to be your new figure over your old figure. So in this case right here, if I said what the scale factor was from ABC to MRG, you would say my scale factor would be 2. because it would be 2 over 1. And this would be from triangle ABC to triangle MRG. But my scale factor will change depending on which way I'm going. If I said the scale factor from MRG to triangle ABC, well, my scale factor in this case would be 1/2. So if I'm going this way, the bigger triangle is 2 times as big as the smaller triangle. If I'm going the other way, the larger triangle, or the smaller triangle, is half the other triangle. So your scale factor can be 2 things depending on what direction you're going. There is a letter that we use, scale factor. The letter K is always used for scale factor. Okay, I don't really have a reason. So the scale factor of 2 triangles is 4/5. The side of one triangle is 15. Find the measure of the corresponding side of the second triangle. So all you would do, because it's giving you the scale factor here, and it's giving your original triangle is 15. So you'd say 15 times 4 over 5. Okay, and so that would be 60 over 5, which would be 12. And so that's all you have to do, is you have to just multiply by your scale factor to go from one figure to the next. Okay? And I know this is actually going to be if my scale factor is less than 1, my figure is getting smaller. If it's greater than 1, it's getting bigger. All right, so we're going to talk a little bit about similarity. So we said that for 2 figures to be similar, the corresponding angles must be congruent and the ratio of the sides must be proportionate. So for this one right here, are these 2 similar? Well, we're going to say no, because the corresponding angles are not congruent. Okay. I go to this one, first thing I check, okay, I know that so we're talking about this triangle and then the triangle here. Well, all the angles are the same. Are the sides proportionate? So I look at my sides. I know this side, let's say, is 1 tick, this is 2 ticks. This is 1. So let's say this is x and x. So this would be 1x over 2x. This would be, say this side is y and this side is y, so the whole side here would be 2y. I know this would be y over 2y. And my third side would be 11 over 12. Are my sides proportionate? Do they have the same fractions? Well, these x's divide out. We have 1/2 here, 1/2 here, and this should be out of 22, excuse me. And this is also, 1/2 here. This is not going well for me. Sorry about that. Okay, so yes. Angles are congruent. Sides are proportionate. Okay, those are the things that you look for. This next one, I look first, I want to make sure that the angles are congruent. So we have 37 and 37, but I don't know these 2 angles, so I subtract from 180. So this is going to be 180 minus 37 minus 27, which is 116. Which means that, since this is also 116, that this angle also has to be 27. So the angles are congruent. That's the first thing you check. Now I look at my sides to see if they're proportionate. So I always do small side over small side. So I have 4x over 5. Medium side over medium side, let's go 4x over 5x, 8y over 10y, and 12z over 15z. Are they all the same fraction? Are they proportionate? Well, the x's divide out. This is 4 over 5. The y's divide out. The common factor of 8 and 10 is 2, so this is going to be 4 over 5. The z's divide out. 3 goes into 12 4 times. 3 goes into 15 5 times. So for this, the sides are proportionate, and so they are similar. Okay, last one. So I know this angle and this angle are the same. I know these angles both have to be 130, and if we keep going around, they're parallel. All the angles are the same. So the angles are congruent, now I look and see if the ratios of the sides are proportionate. So is 15 over 5, so I'm doing right over left, is that equal to 40 over 8? So 15 over 5, if I simplify, is going to be 3 over 1. 40 over 8 is actually 5 over 1. So this is going to be no, they're not proportionate. Okay, so sometimes they are, sometimes they aren't. The last thing, so right here is a scale factor, is 1/2, and this right here is also a scale factor, is 4/5. So it could be 4/5 or 5/4, just depending on if you're going from smaller to larger or larger to smaller. For this one up here, the scale factor is 1/2 or 2 over 1 or 2. Okay, so we can use the fact that if two figures are similar, they have proportionate sides. So for this right here, it says triangle ABC is similar to EDC. So I know, like, side AB over ED is equal to side BC over DC, which is equal to side first letter, last letter, AC over EC. Okay, AB is 8. I know ED is X. BC is 5. DC is 2. AC is Y, and EC is 3. So I have a proportion, I have 3 parts to my proportion. I just have to figure out which one I can solve. So I could solve this one right here. Okay, so I'm just going to write 8 over X equals 5 over 2. So that's going to be 5X is equal to 16. Divide by 5. X is equal to 3.2. Okay, and then the next one, I can also solve this proportion on the other side using that same thing. So use the parts of your proportion to solve that are not that don't have variables in it. So this is going to be 2y is equal to 15. I divide by 2. Y is equal to 7.5. And so that's that. Okay, so last thing. Again, we're told that they're similar. So I know things like AB over AD, I'm just looking at my similarity statement, is equal to BC over DE, which is equal to AC over AE. Okay, so then I write everything in. So my distance from A to B is 2. My distance from A to D is X plus 2. My distance from B to C is Y. My distance from D to E is 6. My distance from A to C is 1. My distance from A to E is going to be 4. I look at this, I have this 1/4 here. This is the ratio that I'm going to use to solve my proportions. So I know things like, I know 1 over 4 is equal to y over 6. I also know that 1 over 4 is equal to 2 over x plus 2. And 1/4 is also my scale factor. So I cross multiply. So it's going to be 4y is equal to 6. So y is equal to 1.5. I cross multiply this way. I have x plus 2 is equal to 8. X has to be equal to 6. So that's just beginning using similarity statements and solving using similar